AI. So in case you're going in this section, let's focus on Amazon SageMaker AI. Now, before we get started, a short disclaimer. Amazon SageMaker is rebranded as Amazon SageMaker AI. So in case you're going through old documentation, or let's say you're going through resources on the internet and you find the term Amazon SageMaker, and if you're going through latest documentation and you see Amazon SageMaker AI, don't get confused. Amazon rebranded it and now they call it as SageMaker AI. Perfect. Now, what exactly is this Amazon SageMaker AI? So Amazon SageMaker AI is a unified platform for implementing machine learning lifecycle. So it's a end-to-end ML platform. Now this is not just a MLOps platform. When I say end-to-end ML platform, that means organizations can implement their machine learning lifecycle right from creating the models to deploying the models to production and inferencing the models, everything within a single platform. Now, how does SageMaker support this? Very simple. SageMaker has something called Studio, which we'll see in the next lectures. So within the Studio, organizations can set up their domains, maybe one domain per team. And within this domain, SageMaker AI supports bunch of applications. So once you set up a domain, you get access to bunch of applications such as Jupyter Notebooks application, Canvas application. You get access to their pipelines. You get access to their model serving, everything in one place. So this way, once organizations set up a domain and MLOps engineers, once they create user profiles or as they create user profiles and assign them to the users in the organization, they can start accessing these applications and they can perform their activities. For example, MLOps engineer can onboard a data scientist and MLOps engineer can provide access to the data scientist to the Jupyter notebooks so that data scientists can write their training scripts within the Amazon SageMaker AI platform. Similarly, the MLOps admin can grant access to the junior MLOps engineer, where this engineer can use the pipelines application and write the CI/CD pipelines. Other MLOps engineer can work with model serving application or model inferencing. ML engineer can work on packaging, let's say creating the Flask API or creating a container for the trained model. So everything can be performed within a single platform. That's why it's called a unified machine learning platform. Of course, we will see this in action in the next lectures. But for now, just understand it's a unified ML platform. Now you might ask, are there any pros and cons of using Amazon SageMaker AI? Definitely yes. Just like every platform, it also has pros and cons. Let's start with understanding the pros. The first major advantage of using SageMaker AI. Till now, we came across multiple tools. For example, MLflow, Kserve, Amazon virtual machine environment, Kubernetes environment. We came across model serving. If you go with SageMaker, you can just use a single platform. So there is a common platform for everyone. So using one platform is the major advantage. So the collaboration becomes very simple for people in the organization. Now the other advantage of SageMaker, it's a complete managed platform. What does that mean? So the infrastructure for these applications is completely managed by Amazon itself. For example, for training the model, data scientists can spin up Jupyter Notebooks instance, which is, let's say, an EC2 instance where required packages, required setup like Jupyter Notebooks is installed. And this EC2 instance is managed by AWS. So MLOps instance don't have to create the infrastructure required for the training process. Similarly, when other MLOps engineer is working on CI/CD pipelines, they don't have to spin up the required infrastructure. It can be taken care by the SageMaker platform itself. So it's a complete managed platform. Additionally, when you go with SageMaker, the learning curve is less. Not for MLOps engineers, but I'm talking about data scientists or ML engineers. They don't have to learn multiple tools. They can just go with a single platform. For MLOps engineers, the work with Amazon SageMaker actually increases, which I'll be talking in the next lectures. For now, it's good for the organization because the learning curve is less when it comes to these platforms. So these are some pros of using Amazon SageMaker. Now let's talk about cons. Of course, there are some disadvantages of using SageMaker as well. The first one is the costing. Now, till now, all the platforms that we learned, whether it is MLflow, whether it is Kserve, they're all open source and they're all free in nature. But when it comes to SageMaker, because you're using Amazon's managed platform, the costing is decided by Amazon. Today, the costing might be low, but as you keep using the resources, as your data scientists keep spinning up the instances, ML engineers spinning up the instances, the cost can significantly increase because you are not only paying for the infrastructure, but you're also paying for the maintenance for AWS. So there are two pricings, right? One is pricing that is involved for the SageMaker service plus pricing of the infrastructure of AWS. Now the second disadvantage is the vendor locking. Let's say an organization built their entire stack using Amazon SageMaker AI, and 1 year down the line, they want to move away from the platform. It can be because of SLA of AWS, or it can be because of their issues with AWS or costing with AWS. It becomes very, very difficult because you have set up everything within a platform. And this platform is not open source in nature. So tomorrow you want to move from SageMaker to, let's say, Kubeflow, right? Or maybe you want to move to set of open source platforms like Kubeflow plus Kserve plus Kubeflow pipelines plus MLflow. You want to build your own stack. It takes significant amount of effort because here everything is within the Amazon SageMaker Studio. But you want to move to open source platforms, right? So it's not like you take this environment and put it on your open source setup. So these are two major disadvantages when you go with Amazon SageMaker. Of course, on top of that, especially for MLOps engineers, implementing RBAC, implementing ABAC, making sure the cost of SageMaker is low is a very tedious activity. As I told you, I'll talk about this in the next lectures. For this lecture, I hope it is clear what is Amazon SageMaker AI. Amazon SageMaker AI is a unified ML platform where data scientists, ML engineers, MLOps engineers, they all can work within a single platform. That is the studio that is provided by SageMaker AI. So it is basically ML platform where you can take your model from training to production. In the next lecture, I'll show you how to set up your SageMaker Studio, how to create a domain, and how to create user profiles as well. In this lecture, let's see how to get started with Amazon SageMaker AI. It's actually very simple. Just head to your AWS console and search for SageMaker. As I told you, you will come across SageMaker as well as SageMaker AI. Just go with SageMaker AI because this is the rebranded version. So once you click on this, you will get access to the SageMaker AI service. To the left-hand side, you will find a lot of options like domains, images, SageMaker Studio that we discussed, Canvas, notebooks. To get started, the most important ones are the domains as well as user profiles. So you should first understand what are domains and what are user profiles. Very simple. So domains are for the teams. Let's say you want to onboard Amazon SageMaker AI. So you want to onboard your organization to this platform. Obviously, within the organization, you will have multiple suborgs or you will have multiple teams. Let's say like the payments team, transactions team, UI team. So for each team, you will create a domain. And for individuals within the team, you will set up user profiles. And using these user profiles as well as the domains, or using these user profiles within the domain, people can access the SageMaker Studio. Why should someone access the SageMaker Studio? As I told you, all the applications like the Jupyter notebooks, pipelines, MLflow, they are all provided by default in the SageMaker Studio. Let me show you. So if I try to use SageMaker Studio, you will notice I'll click on create a SageMaker domain. So it is asking me to first set up a SageMaker domain, because end of the day, who will use the applications provided in the studio? It should be used by the user profiles. And where will you create the user profiles? You create the user profiles within the domains, right? So we will start with creating a domain. Head to the dashboard, click on create a SageMaker domain. If you already have a domain, then you should head for the domain screen and you will find create domain. Now you have two options here. This is very important to understand. Let's say you are a research scientist, or maybe you are working as a freelancer, you are working as an individual, then you should go with quick start option, because this is very cost effective. And let's say you don't need a team, ignore this option. Go with setup for single user. But let's say you're working in an organization. You should completely ignore this option because this lacks enterprise features. Go with this option, setup for enterprises, because this comes with custom IAM role capabilities. This is very important when we deal with user profiles. On top of that, it also comes with the SageMaker Studio interface. It comes with VPC networking, security groups. It also comes with MLflow, the one that we learned in the previous sections. Perfect. Let's click on setup. There is also a disclaimer here, right? Better for admins with large user groups, but you can always update your account. Click on the setup button. Now you might have a question, who will set up all of this? So all of this is actually set up by the MLOps engineers, but not through the user interface. MLOps engineers will set up all of this using infrastructure as code. It can be using AWS CLI, it can be using Terraform or Amazon CloudFormation templates. But for this lecture, let's focus on the user interface because we are just starting with SageMaker AI. Cool. So let me provide a name for the domain. So I'll just call this as test domain to show you how it works. And then we have to provide a bunch of options. If you are using IAC, we will skip these options. We will directly provide the parameters in the IAC code. How do you want to access the studio? Again, there are two options here. Do you want to go with SSO? That is AWS Identity Center. Yeah, I don't have an organization. That's why it keeps complaining. So I should go with login through IAM. In fact, I would recommend this option if you are a mid-scale company, unless you have AWS Identity Center already implemented. Okay, so what does this option mean? This means the teams and users that you're creating will access the studio using their IAM users, which is actually good, right? Because when you have IAM users already, you can restrict the IAM users. Let's say the data scientist IAM user, you can restrict them to only access Jupyter notebooks. Because why do you want a data scientist to access a CI/CD pipeline? It's completely not required. So IAM can provide you that granular RBAC. Perfect. And then who will use SageMaker? You can add your IAM users at this point, but for now, I'll skip it. I'll cover this in the next lecture. Click on the next button. Okay, what permissions do you want to provide this domain? So we are creating a domain. What activities are we going to perform? Then I have to provide an S3 bucket. This is basically for storing. End of the day, a lot of operations are performed. So you need to provide this domain or the team with a bucket. I'll just reuse an existing bucket. You can also create a new one. Then click on the next option. Here you have different applications. Like, do you want to enable Amazon Q Developer? Do you want to enable Docker? Do you want to enable SageMaker Studio? Of course, we need this. Do you want to have Jupyter Notebooks enable shutdown feature? Do you want Canvas? Do you want RStudio? There are a bunch of applications. We will go with the default ones for now. And even for this, you can customize the user interface. This is just like a sidebar customization. If you disable something here, it does not mean end users can't use Jupyter Labs. It's just that it does not show them in their shortcuts, right? For example, if you're using Gmail, right, or if you're using a Google account, you will see different applications provided by Google, like Google Drive, Gmail. You will see Excel sheet, Docs. This is very similar. If I disable something here, it's just going away from the preview. That's it. Okay. And yeah, these are all the navigation options. Let's skip all of them and proceed with the next option. Select the VPC. I'll go with the default VPC. I'll also select a subnet. So let me randomly select one or two subnets. Security group. I'll go with the default security group. Click on the next. Perfect. We are almost done. Click on the next. Verify all the settings. And then you have your studio ready. Okay, our domain is ready. It took 2 to 3 minutes. Now let's go back to the domain option. We'll go back to the studio. And what does it say? Create a user profile, right? We created the domain. Now it is asking us to create user profile within the domain. Perfect. Let's go back to the domain. Here, there is an option for user profile. So this is the team. And within the team, we created a team. Within the team, we are creating a user profile. That is a user account. Add users. Okay. Now, let's go with the name that it provided. Next. For users, what permissions do you want to grant? Basically, for this user profile, which applications do you want to enable? Like, do you want to enable MLflow? Do you want to enable Jupyter Lab? Let's go with the default and click on the next button. Again, the configuration, like what do you want to see in the side panel? What do you want to see in the navigation bar? This is just the look and feel. So let's ignore it. Let's go with the next. Perfect. Let's review all the settings and click on the submit button. Perfect. Now our user profile is also configured. Remember one thing, this is a user profile. Till now, we did not tie this user profile with an IAM user because end of the day in AWS, everything is with IAM users. Nobody can use this user profile. You should tie the user profile with an IAM user. Only then the IAM user can use this user profile, and from there, IAM user can access the studio. Right now, I'm using the root account. I'm using SageMaker admin through my AWS root account. That's why I can access any domain. I can access any user profile. And from there, I can connect to the studio. How it works in real time, we will see in the next lecture. But in this lecture, just focus on what is SageMaker AI. Okay, perfect. So I'll skip the tour. Now, these are the different options, right? The applications, Jupyter Lab, RStudio. And if you scroll down, you will find service for running the experiment tracking. You will find the service for pipelines. You will find the service for model registry, where you can store the models, you can create the models, and also you have bunch of services for data engineers. So everything within a single platform. Now imagine a data scientist logs into the platform. Data scientists can head to the Jupyter lab. They can create an instance with Jupyter notebooks. If you don't know what is a Jupyter notebook, it's basically like Jupyter notebook is an application using which data scientists can write their scripts in a much better way. Okay, so they can choose an instance like FIGB instance, or these are EC2 instances, right? They'll click on launch instance. They will get an instance with Jupyter notebooks installed. So they can write their scripts, they can train the scripts on the same instance, etc. Or let's say a MLOps engineer is logged into the platform. MLOps engineer can use the MLflow platform. Of course, it's not configured. Or MLOps engineers can use pipelines and create a new pipeline using the visual editor. So this is how engineers within the organization can use SageMaker AI Studio. Right now, whatever we saw is just for understanding SageMaker AI. In the next lecture, I'll tell you how this platform can be used in the organizations in real time. That is how domains are created in real time, how user profiles are created in real time, and how user profiles are tied to the IAM users. So make sure you watch the next lecture as well. In the previous lecture, we learned what is SageMaker AI. In this lecture, let's see how to set it up in real time. Don't worry, I'll explain you things from scratch, taking an example. Let's get started. So imagine there is an organization called example.com. Now let's say this organization has an e-commerce application. Now they are planning to onboard 2 machine learning models to their product. The first model is the user traffic model, with which they get a prediction of traffic in the future so that they can keep their website running 24/7. Second model is for the end users, where end users can access the model and they can get prediction of cost of a product in the future. So decided to create both of these models and ship them to production. They also did a research and they came across SageMaker AI. Let's say this is the business requirement. Now let's understand how this example.com organization onboard SageMaker AI. So the first thing that takes place, or the first thing this organization would do, is they would approach their MLOps team, or if they don't have MLOps team, they would approach their DevOps team. The reason is simple. No, not every company has MLOps team in 2025, 2026. So they either plan to build a team or they expect their DevOps engineers to upskill with MLOps practices. Let's say they have MLOps team just for convenience. So the MLOps team, unlike what we saw in the previous lecture, they start with either infrastructure as code practices or AWS CLI, because manually creating domains, manually setting up studio, user profiles is a lot of work and it's a tedious manual activity. It can also go wrong in many ways. That's why MLOps engineers either go with IAC practices or AWS CLI. Especially for SageMaker, I would recommend AWS CLI. Even the documentation also recommends the same. So MLOps engineers start with AWS CLI and start setting up domains within the SageMaker interface. Now the question is how MLOps engineers decides the number of domains. Same thing what we learned in the previous lecture. MLOps engineers go back to the business. In this case, goes back to the management
and ask the management what is the requirement, how many models are under development, and how many teams are working on this process. So in this case, management communicates there are two models under development, user traffic model and the cost prediction model, and two teams are working on it. So MLOps engineers would set up two domains according to the requirement, one for user traffic, one for cost prediction. Now this is not done. As part of step one, along with setting up domains, this is interesting to understand. MLOps engineers also set up IAM role along with policy or permissions. Now you might ask why this is required. This is important because end of the day, what's inside the domain? No, Studio, and within the Studio, there are applications like Jupyter Notebook, applications like MLflow, pipelines, and these applications are utilizing underlying AWS resources, right? We saw in the previous lecture, Jupyter Notebook use instances. So for Jupyter application to use the instances, it needs an IAM role because end of the day, any service needs a role to use the AWS resources. That's why while creating the domain in step one, MLOps engineers also set up a role, typically SageMaker full access role. And this role is granted to the domain. We will see that in practical how this is done. But for now, this is step one. Now step two. Once this is done, MLOps engineers work on creating user profiles. Again, how they set up user profiles? They go back to the business, try to understand the structure of the teams. Let's say user traffic model, and the team that is working on this model, let's say they have two data scientists, one ML engineer and one MLOps engineer. So technically, MLOps engineers working on the setup, they set up 4 user profiles. Let's say one for the data scientist Alice, one for the data scientist Ram, one for ML engineer XYZ, and one for MLOps engineer ABC. 4 user profiles for 4 people working within the team. Now these user profiles, while creating it in step 2, MLOps engineers also configure applications that are allowed to this user profiles. Very simple. While creating the data scientist user profile, Alice, the MLOps engineers just enable access, let's say to Jupyter Notebooks. Technically, it makes sense because, data scientists don't have to access pipelines or MLflow, for example. And while creating the ML engineer profile, MLOps engineer only allow access to required applications within the domain studio. Similarly, while creating the user profile for MLOps engineer, they would only allow access to applications like pipelines, MLflow, or they would deny access to Jupyter Notebooks because MLOps engineers might not get access to the Jupyter Notebooks that data scientists are working on. This is just for example. What I'm trying to say here, along with this, a proper access control is also set up while creating the user profiles. Now, a lot of people assume the work is done here, but this is where most important part, the step 3 actually starts. Step 3 is very, very critical while setting up SageMaker AI. What happens in step 3? Let's say you only set up step 1 and step 2. Now, Ali's user logs into their IAM user. Let me show you through the console. Let's say a domain is set up and 4 user profiles are set up. Now, Ali's user can access the AWS console through their domain, can access the domain, can access the user profiles. Now, what if Ali's user, instead of accessing their user profile, access the user profile of the MLOps engineer ABC. It's quite possible. They can just access the user profile ABC, open the studio, and tweak the pipelines that are created. Or maybe MLOps engineer access SageMaker through the user interface, access the user profiles, and access the data scientist user profile and change the Jupyter Notebooks training process. So this should be completely avoided. This is what MLOps engineers do in step 3. So what MLOps engineers do here, there is a process called ABAC, attribute-based access control. Once again, attribute-based access control. This is very similar to RBAC, but what exactly happens in this case? MLOps engineers for the user profiles, let's say Alice. Now Alice has an IAM user as well. Within this Alice IAM user, MLOps engineers set up the policy in a way only they can access. That is, the Alice user through their IAM policy can only access the user profile called Alice. This is done through ABAC, where for the user profile Alice, a tag is created, right? And within the IAM policy, the same tag condition is used. So even if Alice IAM user tries to access the access profile ABC, they get an error called permission denied, or this resource cannot be accessed. I know this is slightly complex for people getting started, so I'll just repeat what exactly is done. So MLOps engineers, let's take only one user. In second step, while creating user profile for Alice, they create the user profile and they also tag the user profile something like key is equals to name, right? Value is equals to Alice, right? Or key is equals to Alice, value is equals to XYZ, something like that. This is for the user profile. Now in step 3, let's say Alice user already has an IAM user. Technically, they should have. Now within this IAM user, MLOps engineers would add a policy for SageMaker, where within the policy, they allow access to SageMaker, but while accessing or allowing the access to SageMaker, within the policy, MLOps engineers also set a condition, that is the ABAC condition, attribute-based access control, stating they should only access the resources with this particular tag. So now, even if the Alice user using their IAM user, if they try to access the SageMaker AI UI, they would access the UI, they can access the domain. But when they try to access the RAM user profile, because the tag does not match, whatever tag that they have in their IAM user does not match the tag that's in the user profile, they get access is denied. I'll show you the same thing in the next lecture. Right? We will see this thing in practice as well. But for now, these are 3 major steps that are involved. Step 1 is to create the domains. Step 2 is to create the user profiles. Step 3 is to set up proper ABAC, attribute-based access control, to only allow respective users to access their user profiles so that they don't mess up with others people's work. So this is how SageMaker AI is set up in real time. You know, even if you are asked the same question in the interview, don't just say, I use AWS CLI to create SageMaker AI profile or domain, but explain these 3 steps so that interviewer is convinced that you worked with SageMaker AI in real time. In the previous lecture, we learned the theory part, how to set up SageMaker AI in real time. In this lecture, let's focus on the same things practically. So I have my terminal here, and on the terminal, I have AWS CLI installed. This is the only prerequisite. You just need to have AWS CLI configured on your terminal. In case you don't want to go with it, you can also go with AWS Cloud Shell. It's totally up to you. Perfect. Now let's start with the implementation. Whenever you create a resource in AWS, by default, you have to create that resource within a VPC. Now, this is not only for SageMaker, this is for any resource that you create. So let's first get the default VPC as well as the subnets. If you want to create a custom VPC, it's up to you. You can also implement the same thing within a custom VPC. So right now, I'm not creating anything, but I'm just getting the default VPC ID. Don't copy any commands. I'll share all of these commands in order in the GitHub repo. You will get the link. You can follow the same steps. Right now, just focus on the implementation. Okay, AWS EC2, describe VPCs. I'll provide the region AP South 1. I just have the default VPC. Anyways, in the query parameter, we are only listing out the default VPC. Let's copy the VPC ID. Perfect. Now let's list the subnets as well. Now, why are we listing these things? Because when we create SageMaker domain, we will make use of this VPC as well as the subnet IDs. Okay. So default VPC ID, the one that we just got. Let me replace this here and also provide the region AP South 1. You can go with a different region if you are interested. There you go. So we got list of subnets and list of VPCs. I mean the default VPC and list of subnets. So we will use this information when we create the domain. Let's start with the step 1, that is domain creation. What did we learn in the theory part? When we create the domain, we should assign the domain with role, that is IAM role, so that applications within the studio domain can access the internal AWS resources. So in the first part of step 1, before creating the domain, let's create the role. So we will start with creating a policy document that we will assign to the role. Okay, so this is the policy document. Again, this is in the GitHub notes. Let me call this as trust.json. What is within this JSON file? We are just saying this policy document will be used by the principal SageMaker.amazon.com. So this will be used by SageMaker service. That's it. Let's save this trust.json and let's create the role that will use this policy document. So again, I'll copy the command AWS IAM create role. I'm providing the name of this role as SageMaker domain execution role. Assume policy document trust.json. So this role is assuming this trust.json policy document. In my case, I already have this role, so you can ignore the error. Now finally, because the role is created, let's grant the role with permissions AWS SageMaker full access. This is what I explained in the theory part as well. We will assign the role to the SageMaker domain that has SageMaker full access so that applications can perform the activities that they want to. Okay, let's go ahead with it. There you go. So we created the role and attached permissions as well. Let's get the role ARN so that we can use that in the future. Okay, so this is our role ARN. There you go. I copied it. Now let's start with the second part of the first step, that is creating the domain. In fact, the most important part. So to create the domain, we will use this command AWS SageMaker create domain. Let me walk you through this command. AWS SageMaker create domain, domain name. We'll change the domain name from my SageMaker domain to something. I think I already have this domain. So let me just change it to MLOps demo domain. Okay. Authentication mode, IAM. Again, we learned in the theory part, there are two authentication modes, one for SSO and one for IAM. We'll go with IAM authentication mode. We should also paste the VPC ID, the one that we copied, so that domain will be created within the VPC. Okay. We will also use 2 subnets. Sometimes you might have 5 to 6 subnets as well within a region. So just choose 2 or more subnets, not more than that. Okay. So I've copied the subnet IDs as well. Network access type is VPC only. And then we have to paste the role ARN that we just created for our domain. I copied it, so I'm pasting it here. Finally, the region, AP South 1. I hope the command is clear, right? We are creating the SageMaker domain with authentication type IAM with the name MLOps demo domain within the default VPC, within these subnets, and the execution role that we are providing. This part is the role that we just created. This has SageMaker full access permission, right? Without this, your domain is of no use, because without this, maybe the Jupyter notebooks within the domain cannot create the compute instance or cannot use the compute resources. Perfect. Let's run this command. Now this instantly says, this is your domain ARN, this is your domain ID. But let me tell you something. The domain creation will take time. If you followed the previous lecture, you must have seen. So don't get excited and move to the next steps. Go to the AWS console, search for SageMaker and wait for the status to be available. So if I go to the SageMaker right now in the domains, the MLOps domain demo domain is in the pending status. So we should wait till this moves to in service status. This will typically take 2 to 3 minutes. Cool. So the domain status is in service. So we are done with the step 1, that is domain creation. Now let's go to the step 2, that is creating the user profile. Again, there are 2 parts in it. First, we will create the user profile and we will make sure the tag is assigned to the user profile. In fact, we can do both of them using a single command. AWS SageMaker, create user profile, the domain ID that we just created. I copied the ARN. So I'll just paste the domain ID here. In fact, you can also get the domain ID from the AWS console. Cool. So this is the domain ID. The name of the user profile is Alice profile. The key, I'm just calling it as studio user ID, value Alice 123. And region is AP South 1. What is the most important part here? As we learned in the theory part, this is the very, very important part. When we are creating the user, we are creating it with a key as well as value. We will use the same key and value for Alice IAM user as well, so that we can implement a back. Cool. Let's do this. There you go. So now the user profile is created. If we go to the console, now go to MLOps domain, user profiles, we should see the Alice profile. I'll create another user profile, just for our verification purpose, so that Alice IAM user cannot access this user profile. I'll call this as Abhishek user profile. I'll go with all the default options. Next, 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 and then click on the submit. Perfect. So the user profile is created. Now if we go back, MLOps domain, user profiles, we have 2 user profiles. Good. Let's move to the third step. So what is the third step? Implementing ABAC, that is attribute-based access control. Let's say we don't have IAM user for Alice. Okay, Alice is a data scientist, let's say, and there is no IAM user for Alice. Let's create the IAM user as well. In your organization, you might already have the IAM user. In that case, you can skip this step. AWS IAM, create user, -- username. Alice IAM user. Okay, so the username is created. Again, let's verify. If I search for IAM users, so we should see the Alice IAM user. Right now, there are no tags assigned to it. So this implementation is not complete. We should also provide the tag to this user. So I'll run this command, AWS IAM tag user, Alice IAM user with the same tags, right? The tags that we used for the user profile, we are using the same tags for the IAM user as well. Cool. Let's do this. Now if we refresh, I'll refresh the screen. You should see the tags assigned. Studio user ID, Alice123. Finally, this is a new IAM user. Obviously, we should, like at this point, this IAM user would not have any permissions attached. Technically, if you try to access through this user, right? Access the console through this user, they will not be able to access even the studio, or they will not be access anything on the AWS. So we should assign a policy to this IAM user. Let's do that. So to assign the policy, again, I'll create a policy document, the JSON file. Here, I'll just call it as SageMaker ABAC. Okay, I'm calling it as SageMaker ABAC.json. And let me go through the policy document for you. There are two statements here. Please understand this carefully. Statement 1, we are providing the Alice user with actions. So Alice user should be able to access SageMaker, list the domains. Alice user can, I'm talking about the IAM user, can list user profiles, list tabs, describe domain, describe user profiles, list tags. If you want, you can grant permissions to EC2, you can grant permissions to EBS, right? In this section, you can do all of that. Now there is another statement which is very important, where we are implementing the attribute-based access control. If you see this, condition strings equal this particular key and the value. Okay, I mean this particular resource tag. We are saying studio user ID. So that means this IAM user should only access the resources that match this studio user ID. Cool. So let me save this. And now let's provide these permissions to the IAM user that we just created. That is the Alice user. Of course, I should create the policy. I just created the JSON file. So I'll say AWS IAM create policy from this JSON file. Okay, it says the policy already exists on my console, that is on my AWS account. So now I will attach this policy to the Alice IAM user. I just need the account ID. I can get the account ID from my console. Okay, go back, account ID, copy, paste. Cool. So we are almost done with the steps. Now we can perform the verification. In case something goes wrong in the verification, no worries, we will go ahead and fix the things as well. So now as Alice IAM user, I will try to access the SageMaker AI and see what happens. Okay, for that, let's head to the Alice IAM user, security credentials. Here, I will say enable console access. I can just search for console. Okay, console sign in, enable console access. Let's go with auto generated password, enable the access. Okay, now I'll take incognito window. Okay, private window. And here, I will just copy the AWS URL, the one that we got. Okay, and paste it in the private browsing, the new window that we created. Access. And let's also provide the username and the password. Once again, I'll copy the username, Alice IAM user, and the console password. Great. Let me provide the user here, Alice IAM user password. Sign in. Okay, we all know there will be a lot of access denied because we did not provide permissions to billing resource. We did not provide permissions to the queue resource. That's okay. Let's directly search for SageMaker AI because we granted permissions in the first statement to list the SageMaker domain and list the user profiles. Ignore all of these errors. Click on the domains. Okay. So Alice user can see all the domains, which is fine. Let's go to the MLOps demo domain. Alice user can see all the user profiles as well. Abhishek and Alice profile, both of them that we created. Let's try to access Abhishek user profile. If what we learned is right, and if what we implemented is right, now the Alice user should get access denied. So let's click on launch studio. We should see the permission denied. There you go. Access denied exception. And if we go back to the domain, MLOps domain, user profiles, and if we click on Alice profile, this time we should be able to access the studio. Let's see. So we are redirecting and there you go. We can access the studio. So this is how you should implement things in real time. As I told you, not a lot of people understand this implementation. So make sure you implement these things, learn these things, and explain the same things to the interviewer. Because people assume setting up SageMaker is just creating domain, creating user profiles, but ABAC and RBAC is important if you're working in organizations. There is other way, like, you can also go back to the CLI and you can also create a unique link for a particular user profile. You can just run this command. Okay. So SageMaker, create pre-signed domain URL, provide the domain ID. In our case, I copied the domain ID. I'll just paste it here, the domain ID that I copied, and provide the region. So what I'm trying to do here, I'm showing the other way how Alice user can get a unique studio link. So by running this command, you will get a huge HTTPS link. You can share this unique link only to the Alice user. So maybe you can create a secret file and pass this URL to the Alice user. So this way, they don't have to go to the studio. They don't have to click on the user profile every time, but instead they can just head to the private browsing and paste this URL. Click on it. They will access their unique studio link. However, I would recommend the first approach, because it's more convenient. They might lose this HTTPS URL or, anything can happen. Instead, just ask them to go to the console if they have access and ask them to access the user profile. Anything according to your organization. You can also see here, if you click on this profile link, you will see Alice profile, that is Alice user is signed into the account. Perfect. So this is all for this lecture. In the previous lectures, we learned what is SageMaker AI and how to install and configure SageMaker in real time. However, we are yet to explore few important things about SageMaker. That is how to create a model using SageMaker, how to store the model version, how to deploy the model, and finally, how to serve the model for inference. From this lecture, let's start understanding these things. Especially in this lecture, let's focus on understanding how a model is created and how the model version is stored in model registry. Let me explain you through this whiteboard first. So basically, there are 4 important things. Number 1 is creating the model. Number 2 is storing the created model in the model registry. Number 3 is deploying the model. And number 4 is serving the deployed model for inference. Basically, to make the model accessible to the end users for predictions. Now in this lecture, we will focus on these two things. So we will learn how data scientists use the SageMaker AI to create the model and store the created model within a model registry. We will use S3 bucket as the model registry, which is a very popular choice for SageMaker AI. Now, how will we achieve this? We will follow series of steps to achieve this. And basically, I'm planning to explain you right from the scratch. So first, step one, we will create S3 bucket, which is the model registry. Step two, we will create the domain. However, to create the domain, we will first create the role. We will create the policy document. We will create the role. Then we will attach this role with the permissions, that is SageMaker full access. And finally, we will create the domain with this role as well as the networking configuration. Then we will create a single user profile. I will not focus on ABAC because the main focus is to understand, create and storing the model. Instead of creating user profile, creating IAM user, creating ABAC, I'll just create a user profile and access this studio through the console. And finally, step 4, we will learn how to use Jupyter notebooks, right? So we will learn how to use Jupyter Labs, an application within the SageMaker Studio. And then we will see how an instance is pinned here and how data scientists use the Jupyter notebooks, how they write their Python scripts, how they execute their Python scripts, how a model is created, and finally, how can they push the model to the model registry, that is S3 bucket. As MLOps engineer, you should definitely understand this workflow. So I'll show you everything step by step. Don't worry about the commands. You don't have to copy any commands because I'll share them with you through the GitHub repository. So just focus on the execution. Perfect. So I'll take my terminal. In case you want to go with Cloud Shell, you can also go with Cloud Shell. Let's start with step 1, creating S3 bucket. So I'll create an S3 bucket. I'll just call it as my SageMaker demo bucket Abhishek. Try to keep it as unique as possible. Let's see if I have that bucket. Perfect. So the bucket name is unique enough. So this bucket is created on the AWS console. Cool. Now, next step is to create the policy document. So again, let me remove everything that's in this folder because I've been using this for the previous lectures as well. So I'll call this trust.json, just like previous lectures, and create this policy document. So this has the principal sagemaker.amazonaws.com. So this policy will be assumed by the role. So let's create the role with this trust.json document. SageMaker demo execution role. I must already have this, so ignore the error. In your case, this demo user should be created. The role should be created. Now let's attach permissions to this role. As usual, we will attach SageMaker full access, but along with that, I will also provide it with S3 full access. Why? As I told you, I'll use S3 bucket as the model registry. So through Studio, the S3 full access is required because the role will push the model to the S3 bucket. Perfect. Now we are done with creating the roles. So let's get the default VPC. So I'll query the default VPC. There you go. I'll just copy it. This is required for domain networking. So let's copy the VPC ID. Similarly, let's create the subnets as well. I'm going little fast this time because we already ran these commands in the previous lectures, and we know how to execute these commands and what exactly are they doing. So VPC ID, I'll just copy it and paste it here. Perfect. I'll just take two subnets and paste it for the future reference. There you go. So we have the VPC, we have the subnets, we have the roles created. So let's create the SageMaker domain now. So AWS SageMaker, create domain. I'll just call it as demo domain, right? IAM is the authentication method. Let me get the account ID here. I can get the account ID from my AWS console. Let me switch to that. Copy, paste. Great. Let me also copy the VPC ID as well as the subnets. Sometimes if you're not using the demo default VPC, then you might mess up with the networking configuration. Maybe during the time of inference, your security group might not be open. So make sure you are completely aware of the VPC that you are using. You might have created some demo VPCs just for your reference, just for your learning purpose. Make sure you don't use them. Only use the VPCs that are fully configured. Okay, or just use the default VPC. Copy and paste it here. I hope I did not mess up with the indentation. Let's see. Cool. So the demo domain is being created. Let's wait for the domain to be created. Once again, I'll just clear the screen, copy the domain for my future reference. Let's go to the AWS console. I'm sure this must not be created by now. Yeah. So preparing the domain. Please don't close the browser. You can ignore that because you are running this command through the CLI, but just wait for the domain to be in service state. Cool. So the domain is in service state. So let's go ahead and create the user profile. Okay. So here is the command AWS create user profile domain ID. I copied the domain ID, or you can also get it like just head to the created domain and copy the domain ID. That's all. So I'm calling this user as a demo user profile. This should be created in no time. Now, if we go back to the user profiles, just refresh and a user profile should be here. Let's use this user profile. Again, I'm not creating IAM user. I'm not creating ABAC because I will directly access the studio from my admin user. This is just for the demo purpose. We already learned how things work in real time. Okay, so I'll access the studio. There you go. Skip the tour for now. Now we already saw the different applications that are here. One of the most widely used application in the SageMaker Studio is the Jupyter Lab. So using Jupyter Lab, data scientists get access to something called Jupyter Notebooks. So they usually head to the Jupyter Lab as per their requirement. Let's say they are working on a complex model. Then they might go for accelerate compute. But if they are working on basic model, if they know that the MLP3 medium instance type is good for them with 4 GB RAM, they'll go with the quick start instance, or they can also go with general purpose CPU. Because we are going with the simple model, I'll click on launch now for quick start. So what happens when I click on quick start launch now? Basically, this instance will be created, and within the instance, Jupyter Notebook is available. Now, what is Jupyter Notebook? You can just assume it as an IDE, right? Something that makes data scientists write the Python scripts and execute the scripts, even train the model very easily. I'll show you by creating an instance. So I'll just click on launch now. You'll just see it as a notepad, but it comes with a lot of sophisticated features.
which helps them in executing inline commands, in training the model within the notepad itself. This will take a couple of minutes. You can already see an instance is being created. You should see this action change from starting to available status. Perfect. So you can see the action now open. So when I click on open within the new tab, you will see a workspace that is set up. Perfect. So this is the instance workspace. I'll click on Python 3 and this is .ipynb. Basically, this is a notebook where data scientists write their script. I'll show you by writing a very simple script. We'll create a very tiny ML model. That's the Iris model, something that we used in the previous sections as well. But this time I will go with decision tree classifier algorithm. Okay, so first of all, we will import all the dependencies. So we can create the dependencies as a block. Let me increase the font size. Okay, so this becomes a block. You can execute this block, right, independently. Now, within another block, I will provide the training script. Okay, so I'll provide the training script here. This is the training script. Iris, load Iris, and we are basically preparing the data set and using decision tree algorithm, we are training the model, or we are basically creating a mathematical function where the output is the model. Cool. So by here, a model will be created. We will save the model using joblib_dump. In fact, we can create the model and save the model within the save command or within the same block. And the next part, so till here, the import statements are done. This script here is basically creating and saving the model. Now we also have one more step where the data scientists have to store this created model within an S3 bucket. How will they do it? They can use Boto3. We all know what is Boto3, right? Boto3 is a Python library that can interact with AWS resources. So they can write something like this. Now, S3 client of Boto3, name of the bucket that we created in the first step, and upload this iris model.pkl to the S3 bucket. So this is how they can use the Jupyter Notebook to create the model and save the model. But Abhishek, they can use Visual Studio Code as well. Definitely they can use Visual Studio Code. But basically here, SageMaker Studio is providing them with an environment. This is a very simple model. Imagine they are working on a large model. They need huge compute. Maybe their local machine is not equipped, or maybe their local machine does not have the required resources. SageMaker domain or SageMaker Studio provides them with the resources. They can just log into the SageMaker. They can access this instance, even if they don't have their laptop. Let's say they are working from a different workspace. Still, they can access the SageMaker and get access to this SageMaker notebook or Jupyter Notebook. Now let me show you how they will execute this. So they can execute this block by block by running on this triangle symbol, or they can also execute all of them by clicking on this fast forward icon. But let's go step by step. Okay, so this has executed the import statements. You can see here, Python 3 kernel is idle. That means execution is complete. Now they'll execute this block. Click on this to basically train and create the model. There you go. Model is saved. Again, the kernel is back to idle status. When you are working on a huge model, or when you are working on a regressive training process, make sure you execute the next block only once the kernel comes back to the idle state. So basically you have to look at this. Python 3 IPy kernel is in the idle state, or is it in the busy state? Now finally, because the model is created, let's run this and see if it will be uploaded to the S3 bucket. Let's see if the model registry is updated. I will go for S3 I will open this in a new tab. Cool. So in the new tab, I will look for the bucket, my SageMaker demo bucket. Okay. And within this bucket, there is model artifacts folder, and you can see iris model.pkl. Perfect. This easy how it is by using SageMaker Studio, right? All that data scientists have to do is they just need to log in through their console or dedicated link that is shared to them, right? And then they can run the Jupyter notebook using the fast forward command, and model is saved to the S3 bucket. This is how models are created and models are saved. I'll tell you one thing honestly, this is a very basic model, right? But in real time, they might work with models where there are 50 steps or there might be 100 steps. But end of the day, as MLOps engineer, it doesn't matter to you because this is the job of data scientist. Whether it can be choosing the algorithm, preparing the data set, writing the script, what matters to you end of the day, if the model that is created is pushed to the model registry or not. In case they are not familiar how to push the model to the model registry, you can help them with this piece of code so that model is available for your deployment as well as the serving part. That is what matters to you as MLOps engineer. But why did we learn this? So that you also know how data scientists use this platform. Maybe in case your organization is not using SageMaker, let's say they want to onboard SageMaker, you can also help them with a demo stating this is how SageMaker can be created, this is how data scientists can use, and then MLOps engineers can deploy. In the next lectures, let's focus on the deployment part. Again, it's very, very easy. For now, this is all for the lecture. In the previous lecture, we learned how to create a model and how to store the model in the registry. In this lecture, let's focus on how to deploy the model and serve the model for inference. Let's get started. Let me start with something very important. So in the previous section, when we learned about Kserve, we saw how easy was it to deploy model of pickle file format using Kserve. All that we had to do was to create inference service, and within the inference service custom resource, we had to provide the location of the .pkl file. It can be S3 bucket, it can be GS, or it can be anything else. Now the problem with SageMaker is that SageMaker by default cannot deploy .pkl file format. So we were using sklearn or scikit-learn for creating these models. So when you use scikit-learn, the model will be created with pickle format, but SageMaker cannot directly deploy the pickle file format. It can only deploy .tar.gz file format. So what we have to do, we have to perform two very simple additional steps. Step 1, we have to create inference.py. So basically, we have to create a Python script to explain SageMaker how to inference it or how to make it available to the end user. The best part is that it's a very simple script, and this is common for various models that you try to deploy. So you don't have to change a lot. So it's a one-time activity. You can even copy it from AWS documentation. Step 2, you just have to take this inference.py along with the pickle file that we created in the previous lecture. The pickle file data scientists create and store in the S3 bucket. So we just have to take these files and create .tar.gz. Basically, we have to create a gunzip file format which can be read by the SageMaker. That's all. These are two prerequisites. Once you create this, you can store this in the S3 bucket and proceed with model deployment as well as model serving. And how does SageMaker deploy? The default way how SageMaker deploys. So you take this .tar.gz and SageMaker puts in a container on an EC2 instance, right? So it creates an instance for you. Within the instance, it deploys the model within the container for you. And using this, you can, or end users can, access the model. The best part is that you don't have to do any of this. Like you don't have to create the instance by running a lot of commands through the UI. Just a click of button, you get the instance, you get the container, which is pre-configured with all the dependencies. It can run your model. Don't worry, I'll show all of this to you step by step. And I'll show you two different ways, two popular ways how you can deploy and serve the model using SageMaker. So now let's go to the user interface and start with our steps. Or let me just repeat the steps and then go to the UI. I just want to make sure everyone understands the concept. So basically, with SageMaker, it is little difficult when compared to Kser because Kser can automatically pick up your pickle file and deploy the pickle file using its model runners or model servers. But when it comes to SageMaker, although it supports different file formats, unfortunately, it cannot deploy the .pkl or pickle file format. We have to create inference.py. We have to bundle the inference.py along with pickle file model file and create a tar zip. And this tar zip we will push to the S3 bucket. From there, steps are pretty straightforward, right? Okay, so I'll head to the user interface. This is where we stopped in the previous lecture. I just renamed it from untitled file to iris file. Cool. Now let's start with the first step. As I told you, we will create inference.py. Now there are two ways how people do it. Like some people directly create inference.py and some people create the code folder and place the inference.py within the code folder. Anything is fine. Okay, so I'll open the inference.py and paste the Python script. As I told you, you can get it from AWS documentation or even you can get it from our GitHub repository. There are a few warnings here or best practices, basically to provide 2 line spaces between the different definitions. Cool. Let's try to understand this Python script. So basically, it has a model function, input function, prediction function, and the output function. You cannot change these functions because this is the exact format in which SageMaker expects the inference.py. What is it doing? The model function is getting the pickle file. The input function is taking the input from the user in application JSON content type format. Prediction function predicts the or inferences and tries to predict according to the user input. Output function returns the output. That's all. Okay. Now we have the inference.py. We have the pickle file. As I told you, the next step is to create the zip file, right? In which format? .tar.gz file format. How do we do that? We can either use the terminal. So if you click on the plus button, so here you can get a terminal. From the terminal, you can run the Linux commands and create the tar.gz file. But I'll tell you the best way. Instead of going to the terminal, create another file here. So plus Python 3, and you can create a simple script like this, right? Import tar file, which is a Python library with tar file.open, just like how you open a file and write content to the file in Python using the with statement. In the same way, with tar file.open, so it creates this tar file, it opens in the write mode, and we are adding iris model.pkl and inference.py. Let's say you put the inference.py within the code folder, just change this to code/inference.py. Because in some places of the documentation, you might find code.py, and in some places you might find inference.py. Anyways, okay, let's remove the extra space. We are good. Okay, now when we execute this, a zip file will be created. Let's see. I'll just run this file. What does it say? Model.tar.gz is created. There you go. I can also see it on the left side. Now we will push this model.tar.gz to the S3 bucket. Again, I can extend this file. Like, I can add an import statement here, import boto3. And in the new section, I can just add this piece of content, right? I can just say s3.upload file and import the S3 client. But what I'll do to just write this in a better way, right? I'll remove this and I will add this to the iris file where we already got these dependencies, right? So here we already have the dependencies, boto3. We already created the S3 client. So I'll just add a new cell here. And within this cell, I will add this piece of code. S3.upload file. What is the file? This file. Bucket name. It should be bucket. My bad. Because the variable here is bucket. Model artifacts. Model.tar.gz. Okay. Let me now run this cell. In Jupyter Notebook, as I told you, you can just run a cell instead of running the entire Python file. That's one of the advantages that you get. Okay, run this. What does it say? Model.tar.gz is uploaded to the S3 bucket. Let's see. I'll head to the bucket. I'll refresh this. Cool. So I have model.tar.gz here. It's just uploaded a few seconds ago. Okay, let's go back to the Jupyter Notebook. We created the inference.py. We created the zip file and we pushed the zip file to the S3 bucket. All the dependencies that we learned here are done, right? We satisfied all the dependencies. Now let's head to the step that is to deploy this, right? As I told you, there are two ways. One way, you can write a Python file. Let's say you're good at Python. So you can write a very simple Python file. So I'll call this deploy.py, right? So just deploy.py. And here within the deploy.py, I'll write this piece of code. So this is sagemaker.sklearn.model. So from this, I'm importing sklearn model and now I'm just providing the location of the model. Where do we have the model data? Within the S3 bucket. Let's get it. Don't worry, even this piece of code, you don't have to invent it. It's not a rocket science. It's available in the SageMaker documentation, even in our GitHub repository. The reason why I'm not stressing on this piece of code, because technically this is not even a code, right? We are just using this module and we are invoking the module with the parameters. So there is nothing that we are inventing. Even I am copy pasting it from the documentation. Anyways, model data. So the S3 bucket, this is a zip file, copy and paste the location. Where is it? Here we go. In the double quotes, I'll put this. Now, the role. You have to be little careful here. Don't provide the wrong role, because if you provide the wrong role, you might mess up the entire thing. That is the execution. So you have to use the demo role that we created. Click on the roles, search for the role, demo. We created SageMaker demo execution role. Get the ARN for this, Amazon resource number, and paste it within the single quote. Entry point, inference.py. As I told you, this is the most important. If you observe carefully what's happening here, this becomes the entry point for the container, right? So what is the entry point for the container, which is in the EC2 instance? This file. So if you provide the wrong location of this file, then obviously container will fail the execution. So if your inference.py is within the code folder, just update this file to code/inference.py, right? Here, your entry point should be code/inference.py. Framework version, the latest version is 1.2. So keep it as 1.2. And I forgot to mention one thing. Basically, SageMaker comes with 1.7. So when you create the SageMaker instance, you can just update your sklearn version to 1.2. I have updated it in the documentation. So don't worry. When you follow the docs, you will run the same steps or you will run the exact steps. Okay, we set up the model parameters. Now model.deploy. You can provide any instance type. I'm going with the basic one. Instance count as 1. That's it. This will deploy the model for you. And it will also make the model ready for serving for you. Let me show you. So I'll just run this entire thing. Right? How do I run this entire thing? So instead of creating the .py, I should have created the notebook itself. Let me do that. My bad. So I will change this to rename. I'll just call it as deploy. There you go. From deploy.py, I'll copy this entire code. Even you can run the Python code. End of the day, it's an instance. So what you can do is if you want to run the Python script, just click on the file, take the terminal, right? Plus you will get the terminal here. And in the terminal, you can just run Python 3 deploy.py. But instead, I will use this notebook itself. Okay, going back to the Jupyter notebook. Let me run this thing. Okay, you can see here, as soon as I run it, the kernel went to the busy state because it's actually implementing something for us. So if we go to the models now, here, or just go to the deployment, in the deployment, go to the endpoint, you will see something creating. So what is creating? An endpoint is creating, and within the endpoint, a model is being run. Right? Once this endpoint status is available, then using the URL or using the test inference, we can access the model. Perfect. So this is one way how you deploy and serve using SageMaker. Now let me show you other way, which is even more easy. Okay. So let's say you're new to Python. Abhishek, I find Python difficult, even if this is a simple piece. Don't worry, I have other method for you. Now in this method, go to the SageMaker. Okay. And here, go to the models section. Click on the models, click on deployable models. As I told you in the introduction section, in SageMaker, you can use the existing models or you can deploy your custom models as well. So click on deployable models, click on the create button. Provide the name of the model. Actually, what we are doing the same thing that we written in the script here. Anyways, okay. So I'll call the name of the model. Let's say demo Sage model. Cool. Pre-built container. Let's use that. Container framework. These are all the different things that SageMaker supports. In our case, we have to go with scikit-learn. Abhishek, why should I go with scikit-learn? Because the framework that we choose here in our iris model.pkl, we choose sklearn framework or scikit-learn framework, right? This one here. If you choose, let's say something else, you choose XGBoost, then you should choose the framework here as XGBoost. I mean, on a lighter note, you can compare this with the programming language, right? Understand this as an automated CI/CD platform where you are choosing the programming language or the framework within the programming language. Framework version, choose the latest, hardware type, CPU, and provide the URL for the S3 bucket. Same thing, right? What we did in the program. So I'll copy from there itself. In the deploy.ipnb, I already provided the S3 bucket location. Copy, paste it. I have provided the IAM role ARN. Copy, paste it. So here we did through the commands. Here we are doing manually. Click on the create deployable model. Okay. Once we have the deployable model, we haven't deployed it. We just prepared this statement for now, right? We just prepared the deployable model. Now we have to deploy the model, where we have to provide the instance type and instance count. Same thing. I'll click on deploy button. It will ask me which instance type. Let's go with the lowest cost, number of instance. Keep it to the lowest number possible. And click on the deploy button. So these are the two ways how you deploy and serve model using SageMaker AI. This takes sweet time, right? If your model is complex, this can also take more time. So you have to be little patient for your model to be up and running. Let's see in my case, if my first endpoint is ready, there you go. This is the first endpoint which we created through the program, and that is ready at the moment. It says in service, and my model is also running. So this endpoint interacts with the instance, interacts with the container, which has the model. What is the flow here? Okay, so the flow is that in SageMaker, you choose an instance. Within the instance, we use a pre-built container. Within the container, our model is running. Now we created an inference endpoint. So this inference endpoint will forward the request to the container and forward the request to the model. This inference endpoint should be accessed by the end user. Now, of course, right now we got the inference endpoint, but we can make it more secure in real time by introducing things like API gateway and load balancer. If required, you can also introduce Lambda in between. Okay, so how do you access this endpoint? Just go to the test inference. In the test inference, provide your JSON data. These are the features, sample features. Click on the send request. There you go. So the request is successful. This is how you perform model serving as well as inference using SageMaker AI. I'm pretty sure for the first time, you might find it little difficult, but as you keep trying it, follow our documentation, try to practice it, try to implement 2 to 3 times on different models, you will find it easy eventually. This is all for this lecture. In this lecture, let's see how to delete the SageMaker resources. Typically, how to delete the entire domain that we created. This is very important. Otherwise, you will end up burning a lot of money on your cloud account. So first of all, you cannot directly delete the domain. That's why I'm explaining you the things step by step. So head to your SageMaker service on the AWS account, right? So this is my AWS account. I'll head to SageMaker AI. Let's say you just have one domain, head to the domain, click on the domain, and then go to the resources first. So these resources are the instances that we created. In our case, we created the Jupyter Lab. So I should first delete this. Okay. So stop it and go to the app configuration. Sorry, my bad. Go to the space management and click on spaces delete. So this is the first step. You have to delete the spaces. And once you delete the spaces, then go ahead and delete the user profiles. So head to the user profile, demo user. I just have one. In case you have more, go ahead and delete all the user spaces, profiles. Click on the delete button. You can also do it from the CLI, but the reason why I'm showing it from the UI, let's say you run a command the command gets stuck somewhere or it throws an error, you have to do it manually. That's why I'm showing you the dependency between the resources. Start with deleting the resources, then space management, user profiles. Finally, now you can delete the domain. If you scroll down, you will see an option to delete the domain. This field is generally grayed out. Only once all of these things are deleted, you will see this button enabled. Now I can click on delete domain. Yes, delete my domain, delete. Please do not ignore this because this will cost you much more than the Udemy course that you paid for. So make sure you delete the domain. Otherwise, you will be charged for the instances, you will be charged for the SageMaker service, Studio. Got it? Perfect. So I hope after watching this video, you will delete all your resources. In today's video, we will deep dive into one of the best MLOps platforms, that is Kubeflow. So you will learn what is Kubeflow, why Kubeflow, how it helps in ML workflow and MLOps. You will also learn what are the different components of Kubeflow. Especially, we will deep dive into one of the important components of Kubeflow, that is Kubeflow pipelines. Then I'll also show you how to install Kubeflow pipelines, how to write your very first Kubeflow pipeline by taking a Hello World example. And then we will deep dive into a real world example using Kubeflow pipelines. So we will take a real world model and try to understand Kubeflow pipelines better. This video is going to be very interesting. Make sure you watch it till the end. Even if you don't have any prior understanding of Kubeflow, or if you don't have any prior understanding of MLOps even, trust me, by the end of this video, you will find it significantly beneficial. I also have complete notes that is required. So whatever commands that I execute, I will share a GitHub repository in the description. By following the same, you can also perform the demonstration. So without wasting any time, let's get started. First things first, what exactly is Kubeflow? So to understand that, let's go a step back and start with understanding what is machine learning lifecycle. So just like traditional software development lifecycle, so to build an application, there are various stages that are involved.